I'm going to go back and do that 7-3, and I'm going to take a different approach to see if it makes a little more sense today. Okay, so the first thing I'm going to start with is the slope of any line can be found by taking y2 minus y1 over x2 minus x1. And what this is it x2 and y2 and x1 and y1 are any two coordinates that are found on a line. So it doesn't matter if they're at the far end or if they're the next 2 points closest together. When you take the slope between them and you reduce the slope, reduce the fraction, you're going to get the exact same value every single time. So what happens if I don't know what the slope is? What happens if I don't know what the graph looks like because it's not graphed for me? How do I come up with an equation that says that every point on that line will have the left side and the right side equal each other in the equation? So to do that, I'm going to set this up slightly different. I'm going to take this value right here, okay, and I'm going to multiply it up to here. So I get m x2 minus x1 equals y2 minus y1. Okay? So all I've done is take this up and multiply it to there. That's all I need you to understand for right now. This is the secondary approach to find an equation of a graph given one of two things. 2 points or 2 coordinates on the graph, or given 1 coordinate and a slope. And it allows us to find an equation on the graph or of the graph that will give us an opportunity to find any other point along that graph that we possibly can want to find. All right? So if you look at your book, it says a line through the coordinate -2 and 5 and a slope of 3. So what that is that means then that when I find my equation of this graph, I know that the line is going to go through this coordinate, and to get to any other coordinate, I'm going to use this as my ratio, my slope, my map. 3 up, 1 right, 3 up, 1 right, 3 up, 1 right, and I'll just continue to get as many coordinates as I want. But what I want is the equation of this graph, of this line. So to do that, I'm going to make another point. I'm going to create one that's going to represent any other coordinate on there. And that's x, y. So that'll represent any other coordinate on the graph. Okay, and what it allows us to do is find the equation of this information. A line that crosses through here that has a slope of this. Now again, you could graph it if it makes it easier for you. All right? But just to find the equation, I just simply do this. I substitute now. 3, that's my slope. My y2 I'll make as y, and my x2 I'll make as x. So I go x subtract -2 equals y subtract 5. Okay? So I'm trying to create an equation now. Now this equation can come in 2 forms. Y equals mx plus b, or ax plus by plus c equals 0. Okay? Both forms are used to define a graph. So now I'm going to multiply this through. 3 times x is 3x. This becomes a plus 2 because it's subtract a negative. Times 3 is 6. And y minus 5. All right? So, right from this point, I'm going to find 2 equations. One in the form y equals mx plus b, and one in the form ax plus by plus c equals 0. So to get y by itself, how would I get y by itself? Add 5. Y is equal to 3x add 11. There's the equation. Okay? What's my slope of this equation? 3. What's the y-intercept of this equation? 11. So what's one other coordinate that we know from this equation goes through this point with this slope? What's the other point? 0 and 11. That's a coordinate. I ask you for a point, you give me an x and a y. Fair enough? So there's 2 points. 0 and 11, that might be with this x and y here. This x and y could be anything now. All right? So what I did is I just simply added 5 to get it to there. I want to get this and this to the other side. To get it into ax plus by plus c equals 0. So to do that, I'm going to subtract y and add 5. What do I get? 3x minus y add 11 equals 0. Okay? Slope-intercept form, general form, point-to-slope form. Okay? Those are the 3 forms in which you're going to be required to write out an equation for. It doesn't matter if I substitute any of the x and y's in here, they're going to equal over here. This equation, same thing. Up here in this equation, same thing. Okay? All right. Now, again, I'm more concerned about you finding one you're most comfortable with. You do need to know the other 2. But the one you should be most comfortable with and get a lot of time is this y equals mx plus b. Because that's what we'll go to next year when we graph this. That's what we'll go to in grade 12 when we graph it. We'll consistently use y equals mx plus b because it's the one that you are going to beat to death for the next 1 week here. All right, when it comes to graphing. Okay, so this was the slope to point form. So what did I do? I took the coordinate, I took the slope, and put it into this equation right here. Again, this is not a new equation to you. This is not new. All I did was manipulate it a little bit by taking these 2 here and multiplying it up. This is still slope. y2 minus y1 over x2 minus x1. Okay, I'm not changing it. I'm not forcing you to know a brand new equation. All I'm asking you to do is start right here to get your equation to work it out. Okay? So now, let's say I'm given 2 coordinates now, and not given the slope. So coordinate number 1 is minus 4 and 5. Coordinate number 2 is 6 and 0. All right, I'm going to show you the 2 methods. First method I like the best. Y equals mx plus b. What do I need to find in order to get this and make this an equation? What do I need to find? Slope and y-intercept. Okay? So the first thing I want to do is let's find the slope. Okay, because I can't get, unless I draw it, I'm not going to get my y-intercept. So I'm going to find the slope first. So I'm going to make this x2, y2, and this x1, y1, and I'll find my slope. What's y2?
0.
0. Subtract y1, which is 5. x2, 6, minus negative 4, which gives me negative 5 over 10, which when reduced is minus 1 over 2. So now I put that into my equation. Y equals negative 1 over 2 x plus b. Does anybody remember what I did yesterday at this point to get the b value now? No? Not yet. Did something before that. Does anybody remember what I did? Well, what does x and y in your equation represent? For me? A coordinate. Where's that coordinate found? On the graph. On the line, right? Do I know any coordinates on this graph?
Negative 4 and 5 and 6 and 8.
I do. So if I put those in for x and y, Can I not solve for b then? Because I know they're on the graph, right? So let's put 6 and 0 in for x and y, and then let's solve for b. So y is 0 equals negative 1/2 times 6, add b. 0 is equal to minus 3, add b, right? How do I get b by itself? Add 3. So what's the equation of this line that passes through those two coordinates? Y equals minus 1/2 x, add 3. What was the first thing that I did? Found my slope. After I found my slope, what did I do next? For me? Plugged in one of the two coordinates. Both would work. Both would work. It doesn't matter. If they're on that line, they have to work. Okay? So I plugged it in, and then I solved for it. All right? So now, what I'll do is I'll show you this to get to the same equation, but I'll use this method now. All right? So again, using the point to, so it's x2 minus x1, y2 minus y1. Okay? So again, in order to do this, the very first thing I need to solve for is still my slope. Okay? So I still use this method right here. Make one of them x2, y2, and one of them x1, y1, and calculate my slope in order to do this. So I know my slope is minus 1/2 because I solved for it over here. I'm not going to do the math again, but this is exactly what you do. So far in the two methods, the very first step is done exactly the same. Find the slope. Okay? So I found the slope here. Now, what I'm going to do is I'm going to make this x and this y. So basically what I'm doing is I'm adding a third coordinate to here. My third coordinate is going to be x and y. Again, what does it represent? It represents all the coordinates that are on that line. Because if I find the slope between any of the two coordinates on that line, they're going to equal. So if I use x and y, and I use one of these two guys right here, the slope is still going to be negative 1/2. Has to. Okay, so let's choose one of these 2 points. Let's take this point right here. So let's go x subtract 6 and y subtract 0. Okay. Any questions so far? I multiply this through. Minus 1/2 x add 3 is equal to y. Hey, voila. They're exactly the same. Okay, so this is all that. We're not doing two completely different approaches to finding an equation. I'm using two very similar approaches. And you just find the one that you like the best, the one that you're more comfortable with. Okay? Now, the last thing that we did yesterday is, or the first thing that we did yesterday that we need to do today is change that to a general form. What has to happen? There's two things that have to happen in order to change it to a general form. What are those two things?
Can't be fractions.
No fractions. So what's the first thing that I'm going to do here to get rid of the fraction?
By 2.
Multiply everything by 2? Sure. So I times this by 2, this by 2, and this by 2. Okay? What's 2 times negative 1?
Negative 2.
Negative 2 divided by 2? Negative what?
1.
Sure. Negative 1x. Plus, what's 3 times 2?
6.
And what's 2 times y? 2y. Now how do I get it into that form? What's the second thing that I have to do if there's no fractions?
subtract the 2y and put it on the other side.
Because what am I trying to do?
Make it into general form, so it has to equal 0.
So it has to equal 0. Subtract that over. Minus x minus 2y add 6 equals 0. There's your general form. What's my a value in the general form?
Negative x.
Nope. What do you got? Negative 1. What's my b value? Negative what?
2.
Negative 2. What's my c value? 6. Whatever's in front of the x is a. Whatever's in front of the y is b. And whatever's by itself over here is c. Negative 1, negative 2, plus 6. Okay? So, we know slope-intercept form. We know point-slope form. We know general form. Those are the three that you have to know moving ahead. All right? So this was yesterday. This is what we did yesterday. How many of us are still in the dark? A little bit confused. Unsure of something here. Honesty. I mean, better now?
Yeah.
Better today than it was yesterday?
A lot.
Okay, that's what we're shooting for, right? You just have to get more educated day to day. Absolutely. Okay, now, all right, well, let me start with a couple questions here. Let's look at 152. I'm going to start with this. Identify the slope and a point on each line. Okay, so I've got y plus 7 is equal to 4. Negative what? 3. Okay. So up to this point, when I wrote an equation out like this, when I wrote an equation out with y equals mx plus b, you knew that the slope value, the m value, was always found in front of the x. And we knew that the y-intercept was found where the b was, right? Okay, so in my point slope form, I have y minus y1 equals m times x minus x1. In this form right here, my x, so they ask you for a slope. Okay, let's first do that. What's my slope of this line up here? What's the slope of that line? What is it?
4 over 1.
4 over 1. You sure, Marshall?
I think so.
Anybody want to agree or disagree with them? How many of you haven't a clue? No idea. Why did you choose 4?
Because it's where the m is, which represents the slope.
100%. He's 100% right. Why? Look where the m is located in the equation. It's in front of the axis, right? So that's my slope. Okay, who's that? You want to shut it off, please? Okay, so my 4 is right here. Right? That's where my slope is found. Then it asks you for a coordinate. A coordinate. Somebody give me a coordinate based on the two equations. You say -3 and +7. Agree or disagree? Agree? Who doesn't know? We're all confident in that? Anybody want to disagree? What do you got?
Shouldn't it be -3 and -7? Because if you're going up 4.
All right. I got another case for you. In case you part of the fun. It was intended. I don't know. Right? Okay? You agree? What do you think it is? Jennifer. On the outs of everybody else says 3 and negative 7. Lucky for her, I agree with her.
Where?
Darn right. You get it right. Well, because I'm the teacher, I'm telling you what it is.
No.
You just
Can you
want
tell
it?
Oh, it doesn't matter as long as I say and she says we're okay. Doesn't matter to anybody else, does it?
Not at all.
All right. This wasn't right. This also wasn't right. Okay? The reason being is this. If it's a subtract here, that means you're subtracting a positive number. If it's an add here, you're subtracting a negative number, and that's what changes it to become an add. Okay? Because slope says this. It's y2 minus y1. Positive minus positive, right? Okay? But when does that become an add sign here? When I subtract a negative number. Right? So this number right here is a positive number. If this would be an add, if it was a negative subtracting a negative, subtract a negative 3. Okay? And the same thing occurs right here. This turned into an add because it was y subtract what? What's going to make it an add? A negative 7. Now, this is an extremely important concept to get under our belts because when we graph from here on in, when we do parabolas, when we do square root functions, when we do sine functions, when we do logarithmic, exponential, whatever, if it's inside the brackets, the sign is always going to be opposite to you. It will always be a positive if it's a subtract. And it will always be an add sign if you're subtracting a negative number. Okay? All right? So it's a dirty concept, but eventually you're going to understand that it just happens that way and it will always happen. Whatever graph you do from here on in, there's like 10 different graphs you're going to do. It's always going to be the opposite sign in the brackets. All right? Okay, so here's what I want you to do. Take 1c right now. Do 1c and give me a point and a slope, please. Hey, no worries. Yeah, I do. Sure. Hey, I've got water bottles, so they're in my truck, but I have to get them filled up. Sure. Yeah, yeah. Okay. Marshall? You gotta go downstairs. Yeah. Would I say 1c?
Yeah.
Okay. All right. Let's take the easy one. What's the slope? What is it?
-2.
-2. Right? -2 over 1. It's always good to put the 1 in there because we understand that slope is a map. It's rise over run. So it helps when I ask you specifically for slope. I like to see that. If I was asking you for what the m value is, -2 would work. But slope, I want to see that you know that it's rise over run. Right? Okay. So now I need an x coordinate and a y coordinate out of that equation. Anybody want to give me a shot at this? What's the x coordinate out of this equation? Go ahead, somebody blurt it out. What do you got? 6, and what's the y?
2.
You got 6 and 2? Okay.
-6 and positive 2.
What do you got?
-6 and positive 2.
6, positive 2. Okay.
-2, positive 6.
-2, positive 6. Oh, you're
Sorry,
going
no.
overboard now.
Wasn't it,
Oh, wait,
wasn't
oh.
it negative?
Yeah, 6 and -2, sorry, I meant.
0 and -6? Or 0 and positive? No,
So, anyways, what do you got?
6 and -2.
6 and -2?
That's, but there's one y.
Negative
I think
2
it's
and
6
6.
I have 6
What do you got?
Yeah, it has to be 0 because, it's the higher intercept is 6.
Oh, yeah.
But wouldn't it be the other way around?
Yes.
Again, she wins. Why? Why? Okay, let's look at it.
Why would it?
Alright,
Why does
I
this
know it's
mean?
just confusing, isn't it?
I understand.
But you know what? It really isn't. I'll show you why. Let's look at this.
Show you why. Show you why.
I'll show you why. I drew a y.
funny.
Jeez, there's so many puns today. Okay, so y minus y1, right, equals m x minus x1. Okay, where's everything located? Well, you identified the slope as -2, right? Right? That's where you guys all got this from. That's not it, right? That's where my slope is located. So it can't be both, right? So my slope is -2. Okay? So now I got an x and a y. My x is found right here. Well, where is it? Right there. Right? See where it's located? Exactly the same position. There's my 6. Where's this guy? It's not there. So what is it? Right? Okay? Yeah, so all I'm doing is I'm piecing it together by a puzzle right now without actually knowing the hows and the whys. Okay? The x's and the y's, I guess. I'm just piecing it together. I write out my equation and I'm just picking it off. There's where they have to be, right? That's where they have to be located. Okay? Let's try one more. Okay, you know what I would do right now? After I've written this out, right? Because I'm going to do this next. So here's what I'm going to do. Like that. Okay? So now, okay, what's my slope?
0.
What do you got?
0.
If I have a 0 here, Zach, what's 0 times x minus 3?
0. So it's
It'd be
1.
0, right? So then that x minus 3 would not exist, would it? So what would the value be in front of that?
1.
It is. It is. Right? So that was the trick. There was the trick. I needed to see that. And that's why I put the brackets where I did. Okay, I wanted to understand that there is a value here. Because if they were going to put 0, then that would be all 0 right there, right? Okay? Okay, so there's that one. Now let's look at this again. What's my x and my y?
Positive 3 and 1.
Positive 3 and
Negative 1.
-1. We all got it right this time. Plus 3, -1. Okay? And again, it's because that guy changed. Right? It's an add, which means you've subtracted a negative value, a -1. Alright? Any questions about that so far? Okay. That's it. I'll do parallel and perpendicular lines with you tomorrow. Okay? I want you to get a hold of this today. So work through 152 and 153 today. And we'll worry about parallel and perpendicular lines tomorrow.